Hello and welcome to another exciting chemistry session. This is your host, Mr. Monza. So we are in the series of more concept, and as of today, we're going to look at the calculation of mass using stoichiometric modes. The calculation of mass using stoichiometric mode, or the mole ratio, commonly known as the mole ratio. So under stoichiometric modes, there is need for us to understand that we cannot use the stoichiometric relationship or the stoichiometric modes if the reaction is not balanced. So the emphasis is on a balanced chemical reaction. So ensure that the reaction is balanced. Then from a balanced chemical reaction, we can extract the mole ratios. So if we have a reaction as usual, reactants and products, there are these small letters that I have used against the capital letters. So the capital letters A, B means reactants, then the capital letters C, D means products. Then these small letters A, B, C, and D are called coefficients. So after you balance a chemical equation, for example, H2 plus O2 giving us H2O. If we balance this chemical reaction, so by putting a 2 there and putting a 2 here, so these numbers in front are the ones that we are referring to, the small letters A, B, C, and D. So if we don't have a number in front, it means that we have a 1. It means that we have a 1, and that is right there. So according to the stoichiometric modes or stoichiometric relationship, this is stipulated that the number of moles of hydrogen, I'm trying to use this example here, the number of moles of hydrogen as a single component is divided by its coefficient. This will be equal to the number of moles of oxygen molecule divided by its coefficient will be equal to the number of moles of water H2O, just a single water molecule divided by its coefficient. So this is what we call a stoichiometric relationship. So we can use this relationship to help us determine the number of moles of any of these reactants or products. So for instance, I am given the number of moles of hydrogen. I can use a relationship between hydrogen and oxygen to find the number of moles of oxygen. If I am given the number of moles of hydrogen, I can still link hydrogen to water and find the number of moles of water. So that is the meaning of this stoichiometric relationship. So the number of moles of A divided by its coefficient is equal to the number of moles of B divided by its coefficient is equal to the number of moles of C divided by its coefficient is equal to the number of moles of D divided by its coefficient. So if I am given A, I can link A to B to C to D and find what is unknown. So this is what we call the stoichiometric relationship. In the previous video, we talked about calculating mass using the law of conservation of mass. So So you can either use the law of conservation of mass, or you can use the stoichiometric relationship, but the answer that you will get will still be the same. We can look at a few examples. So I'm going to give a very basic example using water. So if we say we have let me say we have 200 grams of hydrogen reacts with oxygen to produce water to produce water. Say calculate calculate the mass of oxygen that reacted. So we're going to use both methods. That is, the first one, which is the law of conservation of mass, and using the stoichiometric modes, and see if we'll be able to get the same answer. So as usual, the first thing you have to do is write a balanced chemical equation. So this is a reaction between hydrogen and oxygen, giving us water, which is H2O. So if we balance this equation, we're going to have a 2 here, we're going to have a 2 there. Now, if we're using the law of conservation of mass, I said if you're using the law of conservation of mass, identify a substance whose mass is given. So we have this one. So you pick it together with its coefficient. Then what are they asking? Which is the unknown. They're asking you to find the mass of oxygen. So you pick oxygen the way it is. So this will be 2H 2H2 against O2. Then from there you find the relative atomic mass. So the relative atomic mass of this will be 4, and the relative atomic mass of oxygen will be 32. Then if we are given 200 grams of hydrogen, 200 grams of hydrogen, then we say X. So once we cross multiply, we're going to have 4X is equal to 200 grams times 32. So divided by 4, divided by 4. So when we do the math, this will give us, so we can punch on the calculator, 200 grams by 32 divided by 4. So this would give us 1,600 grams. 1,600 grams. So this is the oxygen that reacted. This is the oxygen that reacted. This is using the law of conservation of mass. Now let's try to use the stoichiometric relationship. Let's try to use the stoichiometric relationship. So according to the stoichiometric relationship, according to the law, we say the number of moles of hydrogen divided by its coefficient, which is 2, is equal to the number of moles of oxygen divided by the coefficient, which is 1. Now, the first thing that you have to do if you're using this stoichiometric relationship or the mole ratio is to find the number of moles. So how do we find the number of moles? So to find the number of moles, we know that the number of moles that is of hydrogen. So we're finding the number of moles of hydrogen because this is the component whose mass is given, will be mass divided by molar mass. So what is the number of, what is the mass given? The mass given is 200 grams. This will be divided by, so what is the molar mass? So the molar mass, do not add the 2. As you can see from the formula, I'm just finding the molar mass of H2. So the molar mass of H2 alone, not together with the coefficient. So this will be 2. So this will be 2 grams per mole. 2 grams per mole. This will give me 100 moles. This will give me 100. This will give me 100 moles. So if I know the number of moles of hydrogen, then I should find the number of moles of oxygen. So I will say the number of moles of hydrogen, which I know is 100 moles. I will substitute it in the formula above. So this will be 100 moles. 100 moles divided by 2 is equal to the number of moles of oxygen divided by 1. So if we do the math there, we'll find that the number of moles of oxygen, is equal to 50. So if I know the number of moles, how do we link moles to mass? How do we link moles to mass? So remember this formula. Now you make mass the subject of the formula. Therefore, mass will be equal to the number of moles times the molar mass. So what is the number of moles of oxygen? The number of moles of oxygen that you found is this one, 50 moles. 50 moles. We multiply it by, what is the molar mass of O2? What is the molar mass of O2? So this will give you 32 grams per mole. 32 grams per mole. So 32 grams per mole. So when you multiply 50 and 32, 50 by 32, you are free to use the calculator. 50 by 32, what are we going to get? So we find that we get 1,600 grams of O2. So regardless of the formula that you decide to use, you will still get the same mass, whether you use the law of conservation of mass or you decide to use the mole ratio, will still get the same answer. We can look at a few examples that are highlighted in the book so that we just confirm. So those are just a few steps that we need to follow. So write the balanced chemical equation, deduce the stoichiometric relationship, so that is the mole ratio, then link the compound whose mass is given, ensure that you calculate the mass, After you find the mass, then you find the mass, you find the moles, find the number of moles of the unknown. Then after finding the number of moles of the unknown, then you can find the mass using this particular formula. So we have an example right here. So we are given 2.5 moles. So in this case, we're given moles, and they're asking us to find the mass. So what is the reaction? So the reaction is nitrogen reacting with hydrogen. Then this gives us ammonia. This gives us ammonia. So the reaction of nitrogen plus hydrogen, giving us ammonia, which is NH3. So as usual, when you balance this reaction, you have a 2 there. Then you're going to have a 3 here, a 3 there. Then they're saying in the question we have 2.5 moles of hydrogen. 2.5 moles of hydrogen. So can we find the mass of ammonia? So they have talked about nitrogen. I mean, they've talked about hydrogen. Let me just try to highlight. They have talked about hydrogen and they have talked about ammonia. So hydrogen and ammonia, how do you link these two? So the number of moles of hydrogen is divided by its coefficient is equal to the number of moles of ammonia, NH3, divided by its coefficient. If this doesn't make sense for you, you can still use the easiest method, which is the mole ratio, where you say hydrogen against ammonia, they are reacting in the ratio of, so they're reacting in the ratio of 3 to 2. Then you can find the number of moles of ammonia, because we're given 2.5 moles of hydrogen. So we are given, a different marker, we are given 2.5 moles, 2.5 moles of hydrogen, meaning we don't know the number of moles of ammonia. So when we cross multiply, we get 3x is equal to 5 moles. 5 moles when you multiply. So divided by 2, divided by 2. So in this case, there is no need for us to, or divided by 3, sorry, divided by 3. In this case, there's no need for us to find the moles, because the moles are already given. So it's just a matter of finding the moles for the unknown. So this will be 5 divided by 3, and that will give us 1.67, round off, 1.67 moles. So these are the moles of ammonia gas, NH3. Now that we know the moles, how do we link the moles to mass? How do we link the moles to mass? So we know that mass is given by number of moles multiplied by the molar mass. So the number of moles is 1.67 multiplied by, so what is the molar mass? The molar mass of ammonia. So it's supposed to get 17 grams per mole. So 17 grams per mole. So when we do the math, this would give us, by 17, this would give us 28.3. 28.3 grams. So that is how we move from number of moles mass. So whichever method you use, some people find this one to be very easy, where they just state the mole ratio, but it's the same as the stoichiometric relationship. It's one and the same. Or you do this, so you put the number of moles there, which is given as 2.5. The mass is just the same. So what is important is moving away from the moles and going to the mass. So doing that calculation, so we get the number of moles, which is 1.67. Then moving from the moles to the mass, we definitely get 28.3. So they can give us all sorts of questions. What is important is, are you able to move from moles to mass? So if you are given the moles, well and good. So work with the moles given, find the moles of the unknown, then link the moles of the unknown to the mass. Then you definitely find the mass. So that is just another example right there. We have been given 0.45 moles of carbon dioxide. So if you look at carbon dioxide, then they're asking you to calculate the mass of carbon. So if this equation is balanced, they are talking about carbon monoxide and carbon. So if you look at carbon and carbon monoxide, they are reacting in the ratio of 2 to 1. So if you're given 0.45 moles of carbon monoxide, what would be the number of moles of carbon? Because we're calculating the mass of carbon. So that would be 2x is equal to 0.45 moles. So that will be divided by 2 divided by 2. So the x will be equal to, so feel free to punch on the calculator, 0.45 divided by 2. So that will give us 0.225 moles. So these are the moles of carbon. Now how do you link the moles to the mass? So to link the moles to the mass, now you can say mass is equal to number of moles times molar mass. So the number of moles given is 0.225. Of course, you have to be very consistent with the units. Then what is the molar mass of carbon? So the molar mass of carbon is just 12. So 12 grams per mole. 12 grams per mole. So this would give us 2.7 grams of carbon. So that is how simple the stoichiometric relationship is. So if you're able to move from mass, you're able to move from mass to moles and moles to mass, then you definitely get the correct answer. So we get a 2.7. So we'll continue looking at a few questions under stoichiometric moles or the mole ratio in the next episode. So any questions, feel free to ask in the comment section and they will be attended to. Thank you very much. Bye bye.